What's up, everybody? Today I'm going to be going over what I'm calling the Buffman plate. It's sort of just an idea of a plate that I'm happy with the performance, and overall just I would feel confident in sending that plate to Buffman range. If you don't know about Buffman range, definitely check them out. But yeah, that's basically the whole premise behind this plate idea. It's just something that I would actually send to Buffman range, and maybe I will send it to him if he's cool with that. So yeah, on the screen I'm gonna put up the layup schedule, and then I'm gonna actually show you guys what that would look like. Starting with the strike face. Here we have a 1/4 inch alumina hexagonal tile strike face. In the actual plate, it's gonna be a monolithic silicon carbide strike face. It's gonna be 0.225 inches, so just slightly thinner. This is kind of just like a pre-run or like a trial. So this is what I had, and this is what I am going to be using, just to get an idea of how the current layup schedule will perform. So currently I have the tiles just wrapped in a number 20 mesh. It's stainless steel. I have it wrapped over the edges, as you can see here. It's bonded to the strike face using T88 resin. So it's on there pretty well. And obviously, even though these are individual pieces, it's rock solid. Basically, it's together. So yeah, moving on. The strike face will be laminated using 2 layers of this tri-weave, has Kevlar, carbon, and fiberglass. These 2 layers are alternated, so the materials do not line up. So where carbon is, there should be Kevlar, and then where the glass is, there should be carbon, and so on, just so it's a little bit stronger. Those 2 will go down first, and then the carbon will be the front layer. So this will be essentially your aesthetic layer. I mean, obviously it's going to help reduce fragmentation or particulate coming out the front, but I just like the way this looks better than the tri-weave, just because once this is saturated with resin, the glass kind of disappears, so it's kind of just a carbon Kevlar look, and I'm not really a big fan of that. I much prefer just a plain carbon by itself. So yeah, this is gonna go on the front. It's going to help prevent particulate from coming back out. Moving on, immediately behind that, so behind the strike face, so the frag layer is obviously going to go in the front, and then immediately behind the strike face is going to be 4 layers of carbon fiber, and this is just supposed to be like a super rigid immediate backer to the ceramic. That way the round can be engaged by the ceramic a bit more than if you were to just immediately have your backer. Because when you think about it, obviously the strike face gets hit, and then the ceramic is sort of pushed out of the way, and that obviously reduces some of the energy that the round absorbs. So I want to put the carbon fiber immediately back in the strike face, so it's a bit more rigid, and the round can engage the ceramic for a little bit longer, like literally microseconds we're talking about here, or like fractions of a second, but still. That's the whole reasoning, I guess you could say, behind the 4 layers of carbon immediately backing the strike face. And then so behind those 4 layers is going to be a 14-ounce Kevlar. Here I already had a panel that someone gave to me, so I'm just going to be using that here. But for the actual build, I did get just the fabric itself, and I am gonna turn it into a panel, again using T88 resin. This is 12 layers here, and the layup schedule calls for 14, so just going to be gluing these 2 layers to this already pre-made panel. And so yeah, that's going to kind of go like this. 14 layers of this 14-ounce Kevlar, and then immediately backing the Kevlar is going to be this PE. This is a 3A PE panel rated for 44 Magnum. I'm not exactly sure how many layers it is, but I got an equivalent thickness of 0.20 inches, or a little bit less than a quarter inch, using 40 layers of this UHMWPE that I got from Scar Armor. I'm not exactly sure on the weight, but just as an idea or a reference, this could be around 40 layers, give or take. I don't know, like 5 or something, 5 or 10. Not entirely too sure, but it is rated 3A. So yeah, that's immediately going to be backing our Kevlar. So essentially 2 3A panels plus a little bit of extra material up front. And then we have 7 layers of carbon fiber as a sort of trauma reducer, and to just keep everything really rigid. So yeah, that's the current plate makeup. And the only thing we're going to be switching out, as of what we know right now, is going to be the strike face. Obviously, if we gain more information after the test, things could change a bit. But as of right now, the only thing we intend on changing is the strike face, and obviously this panel. We will not be using this pre-made panel, but instead we'll be making our own with this 14-ounce K29 fabric that we already purchased. So yeah, now I'm going to get into actually making this pre-trowel plate, and then I'll see you guys once that's done. That's a huge crater. Oh no. Oh, you hit low. Okay. I thought I went through for a second. It's not that.
The other one just hit the bottom?
Yeah. There's barely anything on the back. Very minimal. Let's see if I can get this side. Hit number 2, at least 2 inches apart. The frag coating doesn't really seem to be working. Oh, that's super cool.
Did I get it?
That's the round right there. Or at least part of it. Dude, there's bees all over me. So sketchy right now. A little bit more back face, but honestly, not really too bad. Oof. I'm not too sure what happened there. Is this 2 hits?
Okay, so here's the plate. The first 2 hits, I think, were pretty good. Obviously, the fragmentation layer or particulate layer didn't really work all that much. But yeah, we have 2, I think 3 and 4. And then obviously we have this super low shot, and then this super top right corner shot. I think this might be a hit as well. So this one definitely came out the top. This one blew out the top right as well. And then the bottom one punched through the bottom. I'll have to see like how much material that actually hit, because I mean it is very close, but I think it did hit everything, so not too sure on that. So yeah, top right hit. This hit looks like it went up and then out. This hit looks like it was stopped right here. Then we obviously have these 2 relatively well placed hits, 2 inches roughly apart, and both of those were stopped initially with a very minimal back face. It's kind of hard to tell the back face now, but still, from what you can already see, it's pretty minimal. So let's just take this outer cover off. Bunch of ceramic pieces. Okay, let's get like an initial close-up. I believe I saw a lot of the round in this one. Get this ceramic piece out. Yeah, look at that. If it'll focus. Some light in there. But yeah. This piece is obviously separating a little bit. I forgot to do the little Kevlar straps that I did in the previous video, so obviously I think that would have helped a little bit. Here's the back. Obviously that penetrated. This looks like it, not really sure. Partial penetration. And then obviously this is I think the last hit. But obviously the first 2 hits, very minimal back face, almost like nothing here and here. And obviously this came through. And then I think 2 shots came out the top. Okay, I'm gonna try and take this apart now. Okay, so now I'm gonna attempt to take this apart. It's basically already coming apart, especially the Kevlar. Very rigid carbon fiber. This is 8 layers, or no, 7. This is 7 layers. My bad. Formed really well. First 2 shots very minimal compared to this next shot. Obviously this one came out the top, as you can see here. This one I'm not really sure. Looks like it was sort of stopping some of it, but it hit the very edge. It looks like it hit all the material. Maybe it just didn't hit a tile. Moving on to the PE. Let's try to take this apart. This, honestly, pretty rigid still. A couple more fragments from the round that was attempting to pass through. Here is the round, one of the last rounds that hit. See if I can get this better. Right there. You can see the first 2 didn't even really make it to the PE. This one hit a damaged area, and then it did make it to the PE, but looks as though it stopped. Or most of it stopped. I'm sure some of it came out the top right there. Delamination on the PE. Honestly, could be worse, but it could also be better, I think. I think it's good enough for what we're going for. So I guess I'll plan on continuing to use this for the official version. Some more of the round that hit the somewhat compromised area. Obviously this is the Kevlar, which probably did a lot of the stopping, considering it was the thickest portion and 2 of the rounds didn't make it past it, so this is about halfway through, I think. Maybe a bit more than halfway. See, this one it went a bit deeper than this one. And unfortunately, my chronograph is a bit damaged, we could say. So I didn't get any of the speeds, but roughly previously M855A1, we've been testing it. It's usually going around 3,060 feet per second. So just say around 3,030 to 3,060 feet per second. So there's that information. Honestly, I'm not seeing a lot of like the round for this. Obviously it didn't make it past this, and I don't see anything in here, so unless it just turned straight up to dust, should be seeing something. Dang, bro, this one was, must have not been going very fast compared to this one. Kind of crazy. Where did this one even go? We're like immediately after the strike face. This one just obliterated itself into here. Didn't even make it like past the ceramic. Not really sure what happened with this one. Here's majority of the round, barely after the ceramic, because this is the front of the pre-made panel, and then this is the first of my layer. 14-ounce Kevlar, so M855A1. See the core. Let's get rid of that. Just focus on this. Okay, never mind. There's that separated from this. I don't know if this is the core or the tip. I would assume the tip got pulverized, so let's see, this is steel, never mind. So yeah, what can we conclude? We can conclude that previous testing has led us to come up with a design that is relatively capable. I'm hoping it will perform slightly better with the silicon carbide rather than the alumina. It's going to be a slightly thinner strike face, so maybe they're probably going to like even out, honestly. As you can see, 3 hits, 1, 2, and 3. We at least stopped these 2. We stopped majority of this one. Some of them may have come out at the top. One of these did not hit any tile. Obviously went through the bottom, and then this one skipped out the top. So there's that. Actually confirm, I don't know if this definitely did not. If it did hit any tile, it hit like barely any. So yeah. Carbon fiber trauma reducer, 7 layers. Seems to work pretty well. Maybe like 1 layer of Kevlar on the back to prevent this cracking. I don't know. Seems to be working pretty well as it is, so might just go with how it is. So we stopped 2 rounds of M855A1, well 3 actually. We didn't know the speed, but from previous testing, 3030 to 3070 is kind of the range, but we'll just say like a midpoint somewhere. Probably going around 3045 feet per second. from that pile, but so quick going over what we can maybe change or improve upon. Obviously, fragmentation slash particulate, strike face coating layer did not really perform very well, so we're definitely going to need to up that. Currently we have 2 layers of a tri-weave and then 1 layer of carbon fiber. I definitely want at least 1 layer of carbon fiber on the front, just because I have a sort of a look that I'm going for that I would like to stick to. So definitely have to have 1 layer of carbon on the front. Otherwise, I think we need some Kevlar in here just so it doesn't break apart, as easily. Less brittle fabrics in a sense. So can switch back to the 5-ounce Kevlar maybe. Have like 4 layers of that and then 1 layer of carbon on the front. I'm not really sure if 1 more layer or something is gonna help too much, but the material change to Kevlar might help. Maybe we'll bump it up to 5 layers. 4 layers of Kevlar and then 1 layer of carbon. Because I am planning on wrapping it in, an outer cover, but I'm only gonna wrap the front face like maybe 1 inch in, and then I'm gonna have like a exposed carbon look in the middle. That's what I'm going for. I don't know if I'm actually stick to that or not, but so yeah, we're gonna not have this additional fabric to stop particulate, so I need to think of that when I'm coming up with how many layers I should have. But other than that, not really too much to go off of. I think the Kevlar panel is going to perform better making it myself with the T88 resin rather than the pre-made panel that we have here. Let's see if I can find out which one is a layer that I made. I think the first one and the last one were ones that I made, I think. Not too positive on that, but these 2 pieces seem to be, okay, there's a little bit more than 2 pieces, but there's 3. These 3 pieces seem to be really rigid, and obviously the backing layer has T88 resin on it, so I think it will perform pretty well, at least as well as the pre-made panel, if not better. So we should expect close results as to what performed here with the Kevlar. Obviously, having a higher quality PE would probably help, but I think this did pretty good. it's cheap. So I don't really want to spend like $70 on a nice quality PE plate and then just take it apart. And you know, also this is a good thickness that I like. A lot of PE plates, good ones, are a bit thicker, probably for a good reason. This one is only 0.20 inches, so it works out for what I'm using it for, just because I'm trying to be on the relatively thin side of level 3 plates. 7 layers of carbon on the back works really well in my opinion, especially since we don't plan on having any foam in this build, so no strike face foam, no backing foam. Definitely gonna need this carbon fiber on the back. Can maybe even back it with like one more layer of this 14-ounce K29 Kevlar. Maybe, not sure if that would help or not, because obviously I don't want it to crack, so it can have, you know, multi-hit energy absorption, because once it cracks, you know, the next shot over here might absorb less energy. But if it's not cracking, I don't know if it's absorbing as much energy either way. So if you get my point. But obviously we still intend on using that. These 4 layers of carbon right here, I'm not really sure how necessary it is. Obviously I want like a stiff layer immediately backing the ceramic, as I've already explained. It's gonna help the round engage the ceramic a bit longer, I think, or at least that's the theory behind it. But I think actually adding this to the front for particulate fragmentation mitigation might be a bit better of a choice, because obviously I can take 2 layers from here, because this is 4 layers, and still have 2 layers here while actually adding 2 layers to the front without adding any more weight. Or I think this did really well. So let me know if you guys think I should change anything. If there's anything you saw that was very obvious that I should change, obviously write that in the comments. Write down what you think about the performance of the plate. And write down or comment another video idea, because the strike faces take 3 weeks to ship and I haven't even ordered them yet. I plan on ordering them in then like next 2 days maybe. So yeah, with the election, I don't know how shipping times are going to be affected, but this is definitely like a next month type of project. And considering how nicely I would like to make these, I'm gonna probably spend a little bit more time putting them together, make them look really nice. So yeah, thinking I'm gonna make 3 plates, so it's gonna take a bit of time. So in the meantime, while I'm working on this on the side, comment down the next video idea you guys think I should look into making. And with that, I'll see you guys in the next video.